Good afternoon, everyone.
Good afternoon, sir.
Let us start. Remember, we have been learning Chapter 4, Distribution of Oceans and Continents of NCERT textbook, Fundamentals of Physical Geography. Last time we learned about continental drift theory. Today we shall start with a discussion on post-drift studies. Now let me present. Post-drift studies. So post-drift studies here implies studies after the continental drift theory. Okay, studies and discoveries after the continental drift theory. You have learned that continental drift theory was propounded, okay, in the year 1912, and after that so many studies have been done. And what are those studies? Let us read. So here it is interesting to note that for continental drift, most of the evidences was collected from the continental areas in the form of distribution of deposits, distribution of flora and fauna or deposits like tillite. Okay, this we have learned earlier. For the continental drift theory, the evidences was mainly collected from the continental areas, say from the distribution of plants, animals, and deposits like tillite. A number of discoveries in the during the post-World War II period added new information to geological literature. Okay, a number of discoveries have been made after the Second World War and added new information to geological literature. Particularly, the information collected from the ocean floor mapping provided new dimensions for the study of distribution of oceans and continents. Okay, ocean floor mapping, then convectional current theory, all these are post-drift studies. Now let us start this convectional current theory. So Arthur Holmes in the year 1930s discussed the possibility of convection currents operating in the mantle portion, and these currents are generated due to radioactive elements causing thermal differences in the mantle portion. Holmes argued that there exists a system of such currents in the entire mantle portion, and this was an attempt to provide an explanation to the issue of force, on the basis of which contemporary scientists discarded the continental drift theory. Actually, continental drift theory was one of the most widely accepted theory based on the evidences, most acceptable one. But when we talk about the forces for the drifting of the continents, okay, this Alfred Wegener did not explain properly about it. So he mentioned, okay, two forces, that is poleward fleeing forces, and the other one is tidal force, and that two forces were not so strong to drift the continents, and on that basis this continental drift theory was discarded by the scientists. Okay, so this convectional current theory is an attempt, okay, how the continents were drifted in different directions, and this theory is also one of the most widely accepted theory. Now let us learn about it. Okay, what is convection current theory? See here, let us say this is the crustal portion. Okay, so let us say this is the crustal portion, and here this is the mantle portion, and we know that, see, in the this upper mantle portion, let us suppose some radioactive elements are found here. Okay, radioactive elements, minerals like uranium and thorium are found here. And when these radioactive elements are decomposed, okay, decayed, it releases a great amount of heat energy, and that is why the rocks here are melted. Okay, the rocks here are turned into magma, and it is rise upwards. Okay, and as soon as it reaches the base of the crust, it is bifurcated in this way. Okay, one branch is going this side and another branch is going this side, and after traveling these thousands of kilometers, it is cooled down, and again it is rising, it is going downwards. Okay, so here also it is subsided, it is going downward as the magma are cooled down, and so it may again reach the source area in this way, and this is what we call convection current theory. And because of this current of magma just below the crust, okay, this crust, continental crust, is drifted, so in this way. Okay, so this continental crust is drifting towards this side, and this one is drifting towards this side, and some may remain as an island like this. So this is what we call convectional current theory. Okay, any question from your side, boys and girls, regarding the convection current theory? Here this picture also shows about the convection current theory. Okay, see, from the astronosphere, from the this upper mantle, hot magma is rising, and it is flowing, okay, just below the lithosphere, and because of that this continental crust is drifting towards this side, and another continental crust is drifting towards this side. This is what we call convection current. So in this way, the continents of the world were moving away in different directions due to the convection current. Okay. So if you don't have any question, then let us continue. Mapping of the ocean floor. See, detailed research of the ocean configuration revealed the ocean floor is not just a vast plain, but it is full of relief. Okay, ocean floor contains full of relief, so it has these mountains, then plains, plateaus, and valleys. Okay, just like the continent, it has full of relief. Expeditions to map the ocean floor in the post-World War II period provided detailed picture of ocean relief and indicated the existence of submerged mountain ranges as well as deep trenches, mostly located closer to the continental margins. Okay, and mid-oceanic regions were found to be most active in terms of volcanic eruptions. So mid-oceanic regions, these are very long mountain ranges found below the ocean. Okay, that we have learned earlier. See here, this is the mid-oceanic ridge, and here, okay, active volcanoes, series of active volcanoes are found here. And the dating of rocks from the oceanic crust reveal the fact that they are much younger than the continental areas. Okay, see, we have learned a method also, that is radiometric dating. Okay, the dating of the rocks from the oceanic crust reveal the fact that they are much younger than the continental areas. That means the age of the rocks, okay, on the oceanic crust is much younger than the continental areas. Okay, see here. Here, these rocks, age of the rocks found on the ocean is much younger than the rocks found on the continent. That is the point mentioned here. Okay, age of the rocks found on the ocean floor is much younger than the rocks found on the this continental crust. Then rocks on either side of the crest of the oceanic reefs have equidistant locations. Having equidistant locations from the crest were found to have remarkable similarities both in terms of their constituents and their age. See here again. So this is the mid-oceanic ridges. Okay, this is another one. And here, see, rocks found here, for example, equidistant. Okay, rocks found here and rocks found here, having the same distance from here. Okay, having the same distance from the crest. So this is what we call crest. Okay, and found here. Let us suppose these two places have the same distance. Okay, have the same distance from the these oceanic reefs. And as mentioned in our textbook, the age of the rock found here and found here the same, and the characteristics of rocks found here and found here are the same. Okay, the type of rock, the characteristic, the nature of the rocks found here and here remain the same. That is the point mentioned here. Okay, rocks on either side of the crest of the oceanic ridges having equidistant locations from the crest were found to have remarkable similarities both in terms of their constituents and age. So these are the important post-drift studies. Okay, these are the important discoveries, findings after these continental drift theories. So we shall learn in detail about this later on also. So at this time, do you have any question, boys and girls? Do you have any questions regarding these post-drift studies? Nobody is responding.
No, so.
Okay, then let us continue. So next we have this ocean floor configuration. Okay, this is about the relief of the landform, you can say, or landscape of the ocean floor. So let us read. Here actually in this section we shall note a few things related to the ocean floor configuration that help us in understanding of the distribution of continents and oceans. And we shall study about the ocean floor configuration in chapter 13 later on. Okay, in chapter 13 we shall discuss about ocean floor configuration in detail. And now we shall learn only the broad, okay, configurations. Let us read. The ocean floor may be segmented into three major divisions based on the depth as well as forms of relief. Ocean floor can be divided into three sections. Okay, and these divisions are continental margin, deep sea basins, and mid-oceanic ridges. Okay, so let us continue. The first major division of the ocean floor is the continental margin. These form the transition between continental shores and the deep sea basins. Okay, continental margins form the transition between continental shores and deep sea basins, and they include continental shelf, continental slope, continental rise, and the deep oceanic trenches. And out of these, the deep oceanic trenches are the areas which are of considerable interest, okay, insofar as the distribution of oceans and the continents is concerned. Okay, so when we discuss about the distribution of oceans and the continents, these deep oceanic trenches are very important. Okay, information collected from the deep oceanic trenches are very important. Now let me show you a photograph. Okay, so this is a diagram showing the continental margin, and here this area, okay, this area shows the continental portion, and here we have the shoreline. And the continental margin refers to the areas from the shorelines up to the this continental, up to the end of the continental rise. Okay, see here, from here up to here. So here we have continental shelf. So this is a gentle slope areas. After the continental shelf, we have continental slope, very steep slope areas, and after this you will find continental rise. Okay, so continental rise is adjoining with the abyssal plain, that is deep ocean floor. And here, see, this is an example of the submarine canyon. Submarine canyon, you know, this is a deep river valley like basins. Okay, deep long basins. So these are known as submarine canyons. So about this we shall learn later on, okay, in chapter number 13. So this is about continental margin. Then the next important major division of ocean floor is abyssal plain or deep ocean plains. So these are extensive plains, okay, that lie between the continental margins and the oceanic ridges. The abyssal plains are the areas where the continental sediments that move beyond the margins are deposited. That means these are the plain areas where sediments from the continents are deposited. Okay, so here we have this diagram. Okay, see here, this is the, so this section, okay, this section is what I call this abyssal plain or deep ocean floor. Okay, and we have learned that see, from here and here is known as continental margin. Okay, from here to here continental margin. After continental margin we have this abyssal plain. Next we have the last one, okay, the third important division of the ocean floor, mid-oceanic ridges. This one we have also discussed in the previous chapter. Okay, and this forms an interconnected chain of mountain system within the oceans. So mid-oceanic ridges are the interconnected chain of mountain system within the ocean. Okay, not on the continent, it is within the ocean, below the ocean, and it is the longest mountain chain on the surface of the earth, though submerged under the oceanic waters. So mid-oceanic ridges are the longest mountain chain on the surface of the earth, though submerged under the oceanic water. That means they are under the oceanic water. It is characterized by a central reef system at the crest and a fractured a fractionated plateau and a flank zone all along its length, and the reef system at the crest is the zone of intense volcanic activity. Okay, so again let us see the diagram here. So this is the mid-oceanic reefs, and here we have a series of volcanic eruption. Okay, magma is rising from the astrosphere and it is erupted here. A series of these volcanoes are erupting here in this section, okay, as mentioned here. And see, it is submerged under the ocean water and characterized by the central reef system at the this crest. Okay, and here the reef system at the crest is the zone of intense volcanic activity. So at the crest, here, crest means this. Okay, at the crest we have these intense volcanic eruptions. So along the crest, okay, along the crest here. Crest means the highest point, okay, of a mountain range. See, okay. Okay, see here also. Let me summarize. Okay, first we have this continental margin. Next we have this deep ocean basin or abyssal plain, and last we have these mid-oceanic ridges. Okay, this is the mid-oceanic ridges. Crest means, see, let us suppose this is a mountain range, and here this is known as a crest. Okay, see, let us say this is a mountain range, and this, okay, the highest line along a mountain range is known as a crest. Any question from your side, boys and girls, regarding the these major divisions of the ocean floor? And see some more photographs about the oceanic diagrams. Okay, about the this oceanic. The best example which I have shown you earlier is the mid-Atlantic reef. See here, you are seeing a very long, more than 70,000 kilometer long mountain range below the Atlantic Ocean. So this is known as mid-Atlantic reefs. So this is the best example of the mid-oceanic reefs. Okay, then so let us find some more example. See here. Okay, so here you'll find locations of many these oceanic reefs. We have mid-Atlantic reefs. So here, okay, see here. Here we have these mid-Atlantic reefs, and here we have these in Atlantic Indian reefs, then Southwest Indian reefs, then mid-Indian reefs. So many reefs are here. Okay, then 90 East reefs. So these are the important oceanic reefs found below the sea. So next we have this distribution of earthquakes and volcanoes. Last time we talked about the these causes of earthquakes, then how earthquake waves are propagated, then about the these effects of earthquakes, about volcanoes, types of volcanoes we have already learned. And now it describes about the distribution of earthquakes and volcanoes. And see, if you study a map, okay, this showing distribution of seismic activity and volcanoes given in figure number 4.2. That means this is the map. Okay, there it is mentioning here. So if you study this map in your textbook, that is figure number 4.2, okay, you will notice a line of dots in the central part of the Atlantic Ocean, almost parallel to the coastline. So if you observe this map very carefully, you will notice that here you are seeing a line of dots. Okay, here line of dots. See here, this you are seeing a line of dots here, line of dots, okay, which is parallel to the coast of the Americas. And here these dots represent shallow earthquake centers, and these black dots represent, for example here represents volcanic eruptions, volcanoes. The bigger ones are the hotspots, means the bigger one, okay, the very active volcanic areas. Okay, and so you will notice that a line of dots in the central part of the Atlantic Ocean, almost parallel to the coastline, is observed, and it further extends into the Indian Ocean. So this line of dot is further extend into the Indian Ocean. Okay, see here, a line of the dot is again further extend into the Indian Ocean. So okay, here in this direction, and it bifurcates a little south of the Indian subcontinent, and with one branch moving East Africa, and other meeting a similar line from Myanmar to New Guinea. Okay, then it is again bifurcated, divided into two, a little south of the Indian subcontinent, okay, with one branch moving East Africa and other meeting similar from Myanmar to Guinea. See here, okay, this is the one going here, and again we have to move. See here, again it is see here, one is again here, and another one is also here, okay, and another one is also here, another line of dot in the Indian Ocean. So here this is the Indian Ocean, and this is also the Indian Ocean. And again you will notice that this line of dots coincide with the mid-oceanic ridges, that I have already told you that the line of dots are coincided with the mid-oceanic ridges. Say for example, this line of dot is coincided with the mid-Atlantic ridge. Okay, and this is another one, this is Indian, okay, Indian Ocean one, that see here, that one, see here, Indian Atlantic ridge. Okay, this one, Indian Atlantic ridge. And the rim of the Pacific Ocean, and in general the foci means the focus of the earthquake in the areas of mid-oceanic ridges are shallow depth, whereas along the alpine Himalayan belt as well as the rim of the Pacific, the earthquakes are deep-seated ones. Okay, the focus of earthquakes in the areas of mid-oceanic ridges are shallow. See here, the focus of earthquakes here in the areas of oceanic ridges are shallow. Here in this area, these are also mid-oceanic ridges, and earthquakes here are shallow. The focus, okay, are shallow, whereas in the alpine Himalayan belt, see here in this area, the earthquakes, the focus of earthquakes are deep-seated one. And here also, here in this alpine mountain belt also, here in this area, okay, here in this belt also, the earthquake focus are deep-seated one, whereas along these Atlantic ridges here, then here the focus of earthquake is shallow one. And the map of volcanoes also shows a similar pattern. That means the zone of earthquakes and the zone of volcanoes are similar. Just let us see once again. Okay, here we're seeing these gray dots, okay, as well as the black dots. As I told you, the shallow dots represent shallow earthquake centers, and black dots represent volcanic eruptions. That means these earthquake zones are coincided with the volcanic eruption zones. Okay, here also and here also earthquake zones are coincided with the this hotspot of the volcanoes, and here also. Okay, here also, see here, this is what we call Pacific Rim or the Rim of Fire. Here this is the zone of earthquake, and it is coincided with the active volcanoes. And here this is another earthquake zone, and again it is also coincided with active volcanoes. And likewise here also, and here also this is a zone of earthquake, and again it is coincided with the zone of active volcanoes. So in this way, the zone of earthquakes and the zone of volcanoes, active volcanoes, are coincided. Okay, and the rim of the Pacific is called Rim of Fire due to the extensive active volcanoes in this area. Okay, as shown in the map. See here, this rim, okay, this circle, this rim is known as Ring of Fire, because it is this rim of Pacific Ocean is surrounded by these very active volcanoes, and hence this rim of the Pacific Ocean, okay, these margins of the Pacific Ocean is known as Ring of Fire. Okay, see here, you are seeing a series of active volcanoes. Here we have a series of active volcanoes here, another series of active volcanoes are here, and these are again coincided with the earthquake zones. And here, and this ring, okay, surrounding the Pacific Ocean is known as Ring of Fire. Ring of Fire. Okay, Ring of Fire or Rim of Fire, same thing. Okay, boys and girls, any question from your side about the distribution of earthquakes and volcanoes, or about the ocean floors, about the configuration of ocean floors, or about the convection current theory, or about the mapping of the ocean floors? Of course, about the mapping of the ocean floor we shall discuss in detail tomorrow. Okay, any other question you have?
No, so.
Okay, then let us stop here for today, and please send your names in the WhatsApp group for attendance. Thank you very much for joining my class. Thank you all.